Everyone. Welcome back to my channel. Thank you for your time and being here. I hope you are learning from the experiences that I have. Let's discuss the main agenda for this video. So, in this video, I'm going to cover from data types and operators for Python, just a few notes. This video is does not require any prerequisite. If you are new to learning Python as a programming language, this video can be for you as well. Um, Before starting with this video, it would be recommended to have any Python supported IDE installed to your system. I would recommend and I would prefer Jupyter Notebook for the very simple reason it is very easy to work with Jupyter Notebook, especially for a beginner and from being non-technical background. However, if you know any other IDEs like PyCharm or VS Code, feel free to use that for this exercise used in this particular video. The second thing I would recommend again is a pen and paper along with while watching these videos. I'm going to highlight a number of key points as I promised before and maybe interview questions too and as it comes so that you can note down immediately. Another information is that since I'm going to cover everything from scratch, so this video is going to be a little longer and but it is going to be useful, okay, for sure. So I leave up to you to decide whether you want to watch till the end or not. But I'm going to cover, as I said, the entire data types and operators all from scratch. And let's jump to the journey. All right. Let's get familiar with certain terminology. If you have experience in any programming language, you must be already aware of this one. So this is going to be a revision session for you in context of Python. And but if you're new, then these terminologies are going to be very important for you. For the reason we are going to use them very often and throughout. So the very first point that you should always keep in mind is Python is a case sensitive language. And in fact, there are many other languages which are case sensitive, but there are at the same time other languages where case does not matter, like SQL. So, but Python is case sensitive. You can see the examples here. Class and class, these two are not same. Although we just have a single letter which differs in terms of case. So yes, for Python, they are two different objects altogether or two different variables. They are not considered same. So first and always, because if you are new to the programming language, it's likely that you will make this sort of mistakes and you'll struggle to find out what wrong you made. If you keep this point, then it's going to be easier for you later on to debug your code. Right. Let's second understand the difference between identifier and keyword. Identifiers in general are the names that you assign to the variables, to the entities, to the class, to the function. Again, you may not be familiar with this terminology at this point. Let's understand in simple. All of us have some names, right? All the objects out there have some names. So now, certain object like chairs, tables, that also do have name, but they fall under category furniture, right? So like that, there are very sort groups within Python which has a collection of objects or collection of some objects, right? And they do have names. So any names that we define them or as a user we assign them for our reference, they are all called identifier. So now the question is, can I use any text, any number as an identifier? Like for example, we have names. Do we follow some rule, unsaid rules while assigning name or giving name for a kid or for any newborn baby? Actually, yes. We never give a name that starts with some number. Have you ever noticed like his name or her name will be A1 underscore something? No, right? It always starts with some text, right? Likewise, Python suggests that you need to have an identifier that should be a combination, that can be a combination of letters, can be uppercase, lowercase, digits, and underscore. So these are the valid characters that you can use while forming your name. However, you cannot start the name with a digit. You cannot say one underscore salary. That is not a valid name. However, you can have salary as a valid name, isn't it? So here salary is just can be used as an identifier, okay? Keywords again cannot be used as an identifiers. Now, what are keywords? We'll come to that. We are just trying to compare keywords along with the identifiers, right? So we'll come to the keywords. For time being, understand keywords cannot be used as identifier. Also, we cannot use special symbols like underscore and sorry, except underscore. Any other special symbols like at the rate, hash, dollar, this cannot be a character to the name. Okay, right? We cannot use it. So that's the rule. However, you can use underscore. In fact, underscore is the only valid symbol that goes as a valid character for the identifier name combination. Right? Okay. And last rule says that an identifier can be of any length. So if you are wondering what if my name has 50 characters, is it going to be considered a valid? Well, in terms of length, yes, it is going to be considered valid as long as each of the characters follows the other remaining rules that we just defined. So that is the only thing. Now why we are even talking about the length constraint. That for this very simple reason, in some other languages like C++, there are some constraint on the length of the name that you choose. That's the reason here we are talking about the length, that Python does not have any such constraint. You can have a name with even 100 characters to it. However, each of the characters must follow the rules as given, right? So is that clear? So tomorrow if I ask you, okay, you have to define a variable that can store my temporary result, that variable will be an identifier, and you have to give the name appropriately so that it does not violate any Python syntax. Hopefully that's clear, right? Let's go to the next terminology, which is keywords, right? So what are keywords? And why do we even need to know about it? So as per Python definition, keywords are reserved words. What that means, these are the words which have predefined meaning. Okay, they do have some predefined meaning in context of Python. We may interpret them, understand them. It can have literature meaning outside Python, something different. But within Python, when you come, then they have some predefined meaning, and that needs to be respected. For example, I'm going to show an example, but let's understand what is the constraint. Whenever you know a certain words falls under keyword category, you cannot use them for variable name. It is same as that you cannot have an identifier which are keywords, right? And also, as I said, they have predefined syntax, they have predefined structure, predefined meaning. Mostly the keywords in Python will be of all lowercase. To give you an example of certain keywords, here are the ones. If is a keyword, okay, else is a keyword. Then you have some more like pass is a keyword, continue is a keyword, break is a keyword, for a while. In fact, there's a huge list of keywords that you can go ahead and check out from Python programming, basically program Ms. Again, I'm not sponsoring this website anyway, but it's a good resource in terms of quality. It's a good material. That's the reason I have taken and given as a reference. However, if you know any other website, feel free to use that. Mostly all the websites have a good list for this list of the keywords that we have in Python. Likewise, whenever you want to see the list of the inbuilt functions in Python, you can go ahead either to this website or any other websites that you feel comfortable with. But as long as you're not aware of all the list, you should refer to some resources, and these are the few suggested one. Well, coming back to our examples of keywords, these are the keywords, right? Let me give you a few examples of valid identifiers. Okay, for example, have a look. If I'm writing salary, that is a valid identifier. Okay, if I write even uppercase salary, hold on, uppercase salary, that is also considered valid identifier. I can also write salary underscore uh, one, that is a valid identifier. However, I cannot write one underscore salary, that is invalid identifier. Why so? How do I know it's an invalid? Okay. One thing is, of course, you can run your program. You can run your program would say it's wrong. Another simplest way to identify if the identifier that you have chosen right now is a valid or not, you can do based on the color coding rule. And it is very simple. Let me tell you. Uh, let's take an example of a sample code that has a mix of all possible identifiers that you come across. And let's understand how Python, specifically when you write a Python code in Jupyter Notebook, there are some color codes assigned for each of these groups of the objects. And you can easily understand if you're following some common rules or syntax or not with the help of the color code. And here it goes. So let's see, this is a very simple piece of code. For this code that I have here, code snippet, I'm trying to highlight which is basically your keyword, which is your identifier, which is your string, and etc. I'll come to string, but let's understand. Can you have a look to this graph? It has a lot of information. You have to look through it with patience, because I'm going to again share a lot of information. Note down if you think you cannot hold everything at the point, it's okay, note down. But do that later once I'm done with explaining. Right now, try to listen, because once you listen through what I'm saying, and because I'm going to give some hints to learn them, you'll be almost 90% through of learning this information, right? Let's take this. So within Jupyter Notebook, a certain color codes are followed to clearly understand if the certain basic syntax are followed correctly or not. Okay. So in Jupyter Notebook, any keywords, you will see them with a dark green color. Okay. So keywords are marked if they are rightly written with correct without any error. Mostly keywords are all lowercase, they will turn out green in color. For example, let me go back to my previous example. These are all keywords. Okay. If you are writing some keywords like this, for, and if it did not turn out to be green in color, that simply means you would have missed somewhere in terms of case or spelling or anything. Okay. That's the simplest way to check if you missed anything or not. For example, you see this for turned out to be green, right? Here it's correct. However, this did not. So that means it has some issue, right? So whenever you will write the keywords correctly, that has to turn out green in color. For example, def is also a keyword. Okay, you see that's green in color. If I would have missed in terms of spelling or case, it would have not turned no, it would have not been detected as in green color by Jupyter Notebook. But again, this rule of color code need not be true across any other IDEs that you are using. Mostly these color codes are personalized with respect to the IDEs. The color code that I'm discussing here is specific to the Jupyter notebook, and max to max it can extend to Jupyter Lab. So you have to be careful. If you are using any other IDs, you have to understand the rules of that particular IDs, and in order to debug your code efficiently. Okay, next. Whenever you'll have any inbuilt function, I'll explain that later in detail. For timing, you can mark the word inbuilt functions that will also turn out green in color. Okay, and in fact, light green. Whenever you will write any UDF is a short form of user defined functions that will turn out blue in color. So if they are written correctly, if you see underscore is a valid character while giving some name, I can use underscore. But apart from underscore, if you're using, that will turn out to be something you don't know. If you see, can you see all the black ones? The black ones, what you see, these are variables. These are valid variable names, okay? And if they do not turn out black whenever you are defining some name for the variables, it's possible you have made some syntax error. For example, let's go back to the previous example. See, in all this turned out to be very black in color. But when you look at this one where I was trying to define a variable, it here your part one underscore is not has not turned black in color. That means overall this has some issue. This is not considered a valid identifier, so you cannot use them. This is invalid identifier. Likewise, I cannot use any other symbol. See, the color itself did not turn to black, and if it did not turn to black, it's not going to be a valid character for your identifier. Is that clear? Can you understand? So mostly the identifiers, especially the valid identifiers, will turn out black in color, and that's how you can understand if you have written it correctly or not. Another example I'm going to introduce to you with string. String is nothing but in simple text. In Python, we write text or any text information under quotes. Okay, we'll discuss about it more in detail. So mostly a valid string, that means if a string is written or stored correctly with following the syntax, that should turn out red in color. So these are the examples. Wherever you see red, those are valid strings. Okay, so that you should understand, strings follows red color, valid ones. Okay, all the variables will turn out black in color if syntactically defined. And comment line. Okay, so if you want to write anything which is just for the explanation sake along with your code in the code cell, okay, you have to mark it or convert it to a comment, and a comment can be converted very simply by adding a hash symbol in the beginning of the line, right? So that is done here. So that this is an example of a comment line which also turns out to be light green if syntax is followed properly. I hope you are clear with this particular rules now. Of course, it will take time for you to mug up this rule or to get hold of it. So for time being, you can maybe take the screenshot of this one and keep it for your reference until you really get comfortable with this rule, right? So now going back to the valid case of identifiers and non-identifiers, now I'm sure you're clear how to understand if I have clearly chosen a valid keyword or not, or if I have defined the keywords correctly or not, if the identifier that I took for defining my variable names, are they correct or not? Is that clear? Awesome. Right. So just to give a summary on this part before moving to the next one, that there are three important rules. The first is Python is a case sensitive language. The cases are different. Okay, let's take one more example of that. See, here I have written pass, and pass, as I said, it's a valid keyword. Now, so if I make even one of the characters to something uppercase, now this is not turning it as a, you see, green in color. That means this is now not a valid keyword, rather a valid identifier or variable name. I can use it as a variable name. Okay, so it is recommended that you do not use any keyword as a variable name. Technically you can do that, but it can lead to a result which for which the outcome you cannot predict. It can be some random outcome. It's recommended not to do that practice, so be careful about it. Fine. There are differences between keyword and identifier. It's possible I will use the term identifier very often, or I may say variable name, or I can say function name. Those are nothing but identifiers. Whenever I use any keywords, I'm going to do that. And that keyword should turn out green in color. If it does not turn out, I would have made some mistake. Okay, and if you're worrying at this stage how to use these keywords, will come to that. Okay, we are going to go step by step. Right now we are just trying to understand this basic tokens, the smallest levels, how things are, what are the founding or building elements of a program, and then slowly we'll try to build a small program, then big program, and so on. Right. So far hopefully you're clear. All right, now let's jump to the next set of information for Python, and those are basic data types. So, in real time, we have different information, like we have number set, numbers, right? Few informations we represent with a combination of numbers. We have another set of information like natural languages. Languages are nothing but text data, right? So we have to imitate the similar environment for Python too. In Python also we need those sort of data, and Python should also understand and connect with the real time. The way we process things in real time, the same has to be imitated here too. So to store the same information, so for example, let's say I want to store um, let's say age of a person, right? So what does the age, or how the age of a person is basically interpreted in real time? It can be represented with just in terms of years. So year is nothing but in terms of integer we go, right? You can also store into, so that can I mean, it depends how. If you're just storing year part, that certainly has to be integer, it cannot be fraction. But let's say if you're trying to store in terms of days, that can go fraction as well, right? Floating point, decimal, basically it can have decimal component. Or let's say if you want to store it as a year, date, month, and in that format, then that could be a date time date a date, right? It can be like a string information. You have mostly say it in terms of string, right? So so the same thing, if I have to store and imitate, so to support that, Python has provided some basic data types, a very granular level of data types. Every data that you store will fall to either of these types at a granular level. Okay, at a granular level, Python stores any information to either of these types. Okay, what do you mean by storing of either of the types? That means each of these types have certain properties. Python already understands their meaning, and it knows what set of properties this particular object have, what are supported, what are not supported, to be real with the real-time data. Correct? So here we have, so any information at a granular level you can store either as integer, or you can store as floating point. Basically, any fraction information has to be stored as a floating point in Python. Okay. Any text related data or languages that we talk about, or alphabets, what you say, this all falls under string. You can store them as a string data. Yes, then we also have a set of information called complex number in mathematics. If you have to store in form of complex number, imaginary and real information, that you have to store as a complex type. And then there is a special types in Python that's called bool type, that has just two special integer values, 0 and 1, in terms of true and false, that will talk. So Python do have that special type too. Now, so what you see, like this int is nothing but, okay, let me show you. Int is a keyword, okay? That is a short form. Int is a basically a short form of integer. Whenever you have to store integer data, and if you have to say, or if you're storing an integer information, and it has to say its type, right? So It, instead of saying integer, it will say EINT, that is a short form of integer. Likewise, whenever you have some information which represents some floating point information, that is called float type in Python. If you have any text data that comes under str type or a short form of string type in Python, whenever you have like letters, right, ABCD, or some special symbols to be stored, that all falls under str type. Okay, anything other than numbers you have to store as a str type. And then there's a special set of numbers that can be with the imaginary and real component, which are complex numbers. I think most of our are familiar with the complex number definition from our school days. Yes, the definition remains same here. So whenever you have to store information as a complex number, you have to store or convert that data as a complex type. Okay. Um, Mostly we may not be dealing with complex type in this field. However, these are still used, and these are very crucial whenever you work with some data representing your electricity or current. But I think we hardly going to deal with this sort of data. And then the bool type. Let's take one example to understand them, how they looks like. So um, basically, I said int is an keyword. You can make up now why I said so. The moment I wrote int, it turned out green in color. That's a keyword. Okay. However, we also have int as a function. So this is int as a function, which again turns green in color like we saw before. Then we have float, which is a keyword as well as a function. Then we have str, which is a keyword. Then we have complex keyword, and then bool, that's also a keyword. And the beauty is, corresponding to these keywords, there are keywords if you don't use that parenthesis, but we also have functions, inbuilt functions. So you can use them like this too. We'll see one example, but get familiar with this. Okay. If you ever see them used with a parenthesis, without parenthesis, you have to be very clear. Without parentheses, they are integer keywords. With parentheses, they become function. Of course, you don't have to worry much about how they work down the line. Python knows how to work with them. Whenever they are called with parentheses, without parentheses, what to do, what not to do, right? We just have to understand their application, when to use which one. Okay, that is what we need to do or focus at this point of time. Let's take one example to understand the various properties and flexibility of these data types. You must know these data types very clearly whenever you have to use them. Okay, let's come. This is going to be some informative session right now. What I'm going to discuss, even for those who are from non other sorry for from other coding background, maybe from Java, especially C++ and C, because Python has some different rules when it comes to defining a variable, unlike the languages I just mentioned. Here it is. So if I have to store, let's say, an integer value representing something, what I'm doing here, I'm just have to assign to a variable. This is a valid identifier, which I'm calling like a variable one, var1. Whenever to any variable, you assign just a value like integer value. What happens, this variable will get some type, and what type that would be? That will be int type. Am I saying that look to the variable var1, assign an integer type? No, I'm not saying that, but this assignment means that. Okay, you don't explicitly have to say that, but it means that. Then how does Python understand that I'm storing an integer to it? Because you have just assigned an integer value to it. You know, there's a definition, formal definition of an integer and a floating point number. You know that? Yes. And that's based on that formal definition, Python understands if you have stored an integer to a variable or a floating point to a variable. Just in case you haven't noticed the difference, a floating point number always has to have one dot in between. One dot. anywhere, followed by some number. It can be 0 to the minimum, or if you just write 2 dot, that is also valid. But the moment there's a dot, it is a definition of a floating point or a decimal number. So whenever you assign something like this to a variable, it will be considered a float type. Okay, and whenever you just assign without a dot, that goes as an integer type. So if you have to assign an integer value to a variable, you really don't have to say that with the help of some explicit typecasting. Rather, just assign an integer and Python will convert or assign a particular type to this variable, which will be int type. Okay, right. Now this is an example where I'm assigning an integer type to a variable. This is an example where I'm assigning a floating point type to a variable. Now, next is a string type, right? You remember str type. So whenever you have to assign anything as a string, text data, as a text information, if you have to store to any variable in Python, you have to put that information under quote. Now the question can be, we know we have a different types of quotes used. This is called single quote, this is double quote, then we have single triple quote, and then we have uh, double triple quote like this. So these are the four valid different quotes that those are available. Can I use just always single quote? No. So all these codes are supported by Python. We are going to take one example on each one of them later on, but just in case if you had this doubt, what if I use double quote? You can use, okay? So, but the important thing is it has to be under some sort of quote. So now, the moment you put any information can be text or can be a number, like this, that is immediately considered to be a string type in Python. All right. Okay. Then, if you have to define complex number, all you have to do is follow this format: a plus bj. Now, what is j here? J is a keyword. All right. You cannot use I. I is not supported to mark the imaginary part. Only j is supported. When you assign any this form of information to a variable, that variable will get or become of complex type. And then the last one is bool type. So there are only two values for the bool type: true and false. Those are keywords. Okay, true and false. These are two keywords. These are they have predefined meaning. Okay, they have predefined meaning. You cannot or you should not change their meaning anyway. So they have predefined meaning and predefined value and predefined type. These two falls under bool type. And the again, this I remember I said to you that all the keywords are of lowercase, with the exception for these two. These two, if you see, their first character is always uppercase, and you have to follow that. You cannot write true. This is not a valid keyword. This is just any random identifier. So I do not want to use right now any identifier. I'm talking about the bool keywords, right? Okay. So fine, I assigned some values to some variables, and I said these variables have got some certain type, but how can I validate that they really got the specific type I'm talking about? That you can validate with the help of type function. What does type do? Type function gives the type of a variable. Like for example, you want to check what is the type of the variable var1. So type function will say, okay, it is of int type. It is of int type. Okay. Once I'll run this code, I haven't run it. Once I'll run this code, you'll get to see that this is a float type. This will be right now of str type. This will be of complex type. And this will be of bool type. Okay. I'm just giving you the overview. The result may not be exactly in this form for the various region, but let's run this code. So I'm running this code as I said yesterday. In the previous video, you can run the code either by clicking on the run cell button, or you can press control plus enter on your keyboard. Okay, if you are not familiar with the shortcuts, keyboard shortcuts to execute your code in Jupyter Notebook, watch the previous videos. I have given the whole list and also the reference material very clearly over there. Anyway, so I'm going to run this code and have a look. We got some output. So corresponding to every one line, what, so you can understand print is a function. The job of this function is to display whatever information you give to it on the output console. So this is the output console right now in the Jupyter Notebook, and it's just displaying on that. Corresponding to every print, you have one output. It's 1:1 mapping. You can always understand them. So you see, it says int, it says float, next is float, then var3 is str, var4 is complex, var5 is bool. Now you might be wondering, okay, why there is an extra information called class? Okay, so for the very reason, you don't have to get into this too much. In just if you're curious, I'm answering this, but I'm not going to talk too much about it. In Python, everything is considered to be object type. That means for every variable that you define, uh, these are the instance of some classes. Okay, so Python is totally implemented as an object oriented language instead of sequential language like C++. So if you're not familiar with this terminology like object oriented, sequential, procedure language, just go and Google. But again, these are not mandatory for you to understand rest of the content or in this particular playlist. But if you're curious, you can go ahead and do. I'm sure those who of you are from other programming language or having background in any other programming language, you can connect with that very easily. But if you cannot, just take any Google out any good materials on Google and you can go through that. But again, it depends up to your curiosity how much you can explore. So I leave that up to you. I would recommend here to discard this information called class over here. All you should focus every time on this object called int, float, str, and so on. So as I said, these variables have this particular type assigned. Now you can ask me a question. Okay, well and good. I assign some type, a value corresponding to certain type to a variable. If I wish to change that, that means if I wish to assign some new value to that particular variable, can I do it? And what I will have to do it. For example, let's say now I am interested to assign some string value to variable one for some reason. Don't think about reason right now, but assume you wanna do this. Okay, can I do it? Yes. And what will happen to its type then? Let's see. So in the next example, let me copy the same one, put it here and do it for you. Now, what I'm going to do, I'm going to assign some string to variable one. I can assign a string by giving something like Python. This is a string data. Okay, you have to understand. Now, this is not applicable. So this is a string data. Okay, or I need not do it here. In fact, I can do later also. I mean, I can have both of them together. Initially, I had a value of integer 2 to var1, but now I'm assigning some text data to my var1. Okay, so which value will var1 retain? So that you can see here, what I'm going to do is just copy this var1 and display at the end again. Let's see what happens. So let me clearly give you some idea. First, let's understand what happens and then we'll run it. So initially, in Python or in any language as such, whenever you have multiple lines of code, the code they always run in the sequence of their order from top to bottom. So first this line will be executed, then line number 2 will be executed, then line number 3, 4, 5, and so on. So what will happen in that process? First, var1 will get assigned with a value of integer 2. Hence, the type of this var1 will be of int type. Okay. var2 will be of floating point type, var3 str type, var4 complex number, var5 key bool type. Since we are not manipulating them later, their type will remain to be same. But when again, if you see in line 6 and change assigning a new type of data to var1. So what will happen? var1 will now hold this latest information, whichever is the latest, that will be hold. So what will be the type of var1 after the execution of line 6? That will be basically str type. But you know what? Once line 6 is executed, then only line 10 will execute. So by the time you are at line 10, var1 already got a new type of data, which is a string type. That's why when you'll execute line 10, it will be str type. Now, no matter how many times you print var1 type, it will be all str type. Is that clear? And that's the reason here str type here too, here too. Okay. So 2 points here. Firstly, whenever you have to assign any new type of data or any new value to any variables, all you have to do is assign it. Simply assign it. Immediately, Python will change the type of that particular variable based on what type of information you have assigned to it. You don't have to tell it any explicit way. The moment you follow your syntax correctly for the particular value while assigning to a variable, the type of the variable will change immediately. That's the first point. Second point, whenever you assign multiple values to any same variable, whichever is the latest value in the sequence or last most value in the sequence, that value will be retained. Previous all will be overwritten, right? So you cannot expect a value of 2 after the execution of Python assigned to var1. Is that clear? If you have any other combination, like you can think, okay, what if can I assign to verify some other like integer value? Yes, you can. You can override. Either you do here or you can recopy your code here and you can assign some integer like 3. Of course, you can do that. Okay. So again, what value you really want to assign, that totally depends on what you are trying to achieve. But when it comes to like, can you assign? Yes, you can assign, right? Is this clear? Awesome. Now let's now go to understand what are the properties of these variables or for these types. So we know the properties of an integer is that uh, these are integers. Okay, they will never have any fraction point. Whenever you add two integers, you get two integer. The result value will be an integer. I think we are quite familiar with that, right? Operations with integers. What are the valid operations you can apply on an integer? Of course, arithmetic operations. Those are the valid ones. Or comparison you can do for the two integers. I think we are quite familiar. Okay, nothing new happens in Python. That same goes for floating point and even for complex number. But there are some different way of processing of the string data in Python, okay, which is quite interesting, which it's worth to focus on and learn about it before jumping to using them. So let's go and understand what are the properties of a string data in Python and how to handle it. All right, let's continue and understand how to deal with strings data. Firstly, how can we define them? What are the valid operations we can perform on them? Um, and and then also, what are the properties? That's what we should know. So we are going to make it very simple with taking very small examples for time being to just to understand how to deal with string data. Tomorrow, if I am given a string, let's say, and somebody asks you to just find a particular character in the string. We understand what a character is, a single letter of the string. How can we do that? That can be the simplest manipulation, right? Does not make sense? Okay, let's take another example. So you are given, let's say, a set of a number of names, and you are supposed to find if a particular name exists in that particular string. No? or not. Or let's say, very simple, you have a sentence. Okay, you have a sentence and you want to check if a particular word exists in the given sentence or not, right? Yes, this sort of simple operations you may have to do on daily basis while dealing text data. But how to do that if you are using Python as a language, that is the important one. So in order to do that really efficiently, to think of the logic, you have to understand the strings properties. Let's quickly see. I'll go back on first creating or defining a string data. So whenever you have to define a string data, let's say, how can you do that? As I said, the very simple rule is that you have to put your data in a code. So this is, okay, let's say this is a string data. Okay, even a single character, if you have to store like alphabets A, B, C, D up to Z, you have to put it under code. Now you might be wondering, can I put like a double quote? Yes, you can do that. Or do you want to put in single quote? That is also totally okay. Let's say if you're not convinced with that, you want to put in triple quote, you can do this too. Or you can also use double triple quote. That is totally fine. These all are considered valid string in Python. How do you know? Very simple. Go ahead, check the type of this object, str1. Likewise, let me do it for all others. Oh, I got a mistake. Yes, so these all are valid string as per Python. Uh, so here in all these examples, we see I just have a single letter as a string. Yes. So if you remember, or if you are from C background by any chance, we have a different data type over there for storing a single letter. That's called char type. And to store a sequence of letters, you have something called array. Basically, a word is nothing but a sequence of letters. So we have two different data types, but in Python, you can do all that with a single uniform type called string type. Like that, let's say I want to store a word. Very simple. I can go ahead and do that here too. So that's Python, Python. That's also fine. These are strings. Or let's say you want to have a sentence. That is okay. So Python is easy to learn. That's my sentence. Of course, I can have dot too because for the sentence, I mean, you can think of your linguistic data you have, the real time data, text data, what we say. So that can have a lot of more information. It can have punctuations. It can have many words put together as a paragraph. It can have many paragraphs put together as a chapter, many chapters put together as book. So it can have anything, right? It can have numbers also as a part of its text. Yes, you can also have number. So let's say I can say Python 3 to be very specific rather than Python 2. That's easy to learn. So here 3 is rather not a digit, not treated to be digit, but a character of your string data, right? So this can also go here. We can also copy same thing under same single quote, like here. You can have them on triple quote, like here. Okay. So that is it. Yes, these are all valid string type. Now you might be wondering then why we have so many codes used. Well, it depends. There are some specific technical limitations also for that region and also on preference. So if you're wondering when to use what, I find very comfortable to use double quote and single quote. So I use them based on my mood or based on what I type on my keyboard. But there are some other ones like triple quotes. That becomes mandatory. I mean, firstly, they're difficult to type, so people hardly use them. But there are certain cases or situations where they becomes mandatory to use, and you should know about them. So let me give you some clarification. For a simple string information, you can use any one of them as per your convenience, no restriction on that. But whenever you have store your data across multiple lines, like here. So I'm writing C is says a good student. That's my first line. You know, a paragraph is nothing but multiple sentences spread across multiple lines, right? So it's possible assume that or imagine that you have a paragraph to store which stretches across multiple lines, or I'm typing multiple lines of sentences. Then in that case, my some point I will go to next line, isn't it? And there I'll write something like, okay, so he's a good student, learning Python efficiently, something like that. What happened if you see? Okay, you can ignore the spelling. What happened if you see? Whatever I wrote in the second line was supposed to be considered as a valid uh, string, but that's not happening. How did I make that? Through the color code rule. If you remember, the color code rule says a valid string has to be of red in color on Jupyter Notebook at least. So that did not turn out. Rather, it is treated black in color, which means that's treated as some identifier, which is not true. So if you try to run this code, it will throw you error. Like you see syntax error or end of line. EOL is end of line while scanning. So basically, it was expecting a code at the end of this line like your closing code. But what happened? It did not find. So there's an error. But the moment I push that up, it's going to work fine. You can make out. The color also did change. So how to resolve the previous issue, right? I showed you the issue is I want to write across multiple lines. My sentences, I have many sentences which constitutes to a paragraph, but I'm not able to save as a valid string with just double quote. How can I solve that problem? So let's go back in the next cell. Let me imitate that. To solve this problem or to be considered even this line as a valid string line, what you have to do is you have to use a triple. It is must to use now triple quote. Whenever your information, text information stretches across multiple lines, more than one line, if you want them all to be considered as a valid single string, you have to use triple quote mandatorily. It's up to you whether you want to use single triple quote or double triple quote, but it has to be triple quote. So the must to use scenario for triple quote is this part. Okay, here you cannot work with single quote or double quote. Triple quote is must. You got an idea? I mean, I think this gives you an idea why there are so many quotes coming into picture. Again, you might be wondering, okay, so since triple quote is quite superior to handle most of the scenario, can I use triple quote always? Of course, you can use. The only problem is it's difficult to type on the keyboard. So people hardly use this for all scenario until required because it's difficult to type. All right, so it's related to comfort part. But if you're comfortable to type it, of course, you can go ahead with using all the time so that you'll not have to worry about the special cases, right? Okay, awesome. Given that you are aware of this now, which code to use when, and let's go ahead quickly to understand the properties, back to the properties of strings in Python. So Python says there are three special properties for strings, something called indexability, something called immutability, and concatenation. So these are not just terminology, but there are some limited definition of these words, and some certain operations will fall under these properties. Let's understand them one by one. Okay, so first we'll go with the indexability. What does indexable means? What does it means that strings are indexable? Okay, let's take that example. To understand that, I'm creating a dummy string called my string called Python. Okay, so if you see here, what's happening? I mean, at a granular level, this word Python is nothing but a collection of letters, right? There are many letters put together to form these words. And we also understand that uh, the position of the words has some meaning in to understand the context of the given text. That means you cannot just swap their position and expect the same meaning, same context from the text data, right? For example, Python is easy to understand or learn. That is one sentence where each of the word has certain sequence or position. And now I just change it to like understand and put it here in the beginning. Do these two sentences has same meaning? Not really, right? The meaning has the second line. In the second line, the meaning has totally changed compared to the first line, or maybe it's not even making sense, or maybe it sounds like incomplete. What it's trying to say is difficult to comprehend from just the information given, right? So, what this says in text data, every word, every letter position is quite it has some importance, some significance. Randomly changing them or swapping their position may lead to some distortion of information in your data, right? So you have to preserve that position. You have to somehow preserve. So while working with text data, this each of these characters should have some predefined position such that it will not change automatically until you change it. And Python should also understand that sequence. It should have a way or mechanism to store their position, and it should not by itself change their position for any reason until we are doing it, because we are superior, we are the one we want. So to take care of that, to take care of this position information along with your data that you see on the screen, what does Python do whenever it get a string data? Let's understand with this example called Python. Okay. Now you see, it has every character has its fixed position and it need not be swapped until you do it or changed by mistake when Python is storing this value in the memory. So what Python is doing to understand, okay, look, P is always before Y and Y is always before T and T is always before N. To understand that and to remember that, Python assigns unique integer position or value to each of these letters, starting from left to right. Starting from left to right, it will assign some index number or unique integer number starting from 0. The leftmost will be at index. So these are called index or indices very specifically. So P is at index 0, Y is at 1, 2, 3, 4, 5. Okay. So now I know going from left to right, N is the last most character always, right? So because it has the highest basically index number or integer value. This is at index 1, this is at index 2, this is at index 3, 4. Is that clear? What if I have a sentence, basically a number of words, like here, let's say Python, okay? Okay, let's say we have a sentence called Python is easy and of course to learn. So this is a sentence which has three words, Python, and then each, and then easy. And of course, these words are separated by white space. So how the indices will be assigned to them? So it will be assigned this way. First, Python will be assigned an index of 0, then 1, 2, 3, 4, 5. 5 is for n. And then white space. So is white space also going to index? Yes, it has to. Then only the originality of the sentence will be retained, because in our linguistic, even space has significance. A space between a sentence can change its meaning altogether. So yes, we have to have give an index to this space also, which will be 6. Okay, so two important thing you have to understand. The index while going from left to right starts from 0. You always have to remember this starts from 0. That's first point. Second, even every character or every character that can be a special character, that can be a numeric number, or that can be a dot, or that can be a white space. Every character gets some unique index number. Now there's another white space here. So what index number it will get? So after 6, you have 7, 8, and this will have 9 basically. So this white space has an unique index of 6, and this has 9. They are two different, and they must be reserved accordingly. Okay, that's how Python assigns index number to any given string. Okay, if you have a question, what if you have a blank string like this? So there's a blank. Blank also has an index of 0. Is that clear? Okay. Okay. So let's quickly also check now how can you index and strings. Given that we know for every character there are some unique information, which is basically unique position index number given, which represents position of these characters. So how can you segregate or dismantle the collection of characters into each of the characters using this index number? That is what done under indexing. Okay, so for example, okay, I am interested only to get p out of Python. All right, I want to just extract out p out of Python. That can be one requirement of mine. Maybe I want to do some validation. Okay, so if you're thinking what could be the purpose of it, so let's say you want to check what is the first letter of a particular string, so that based on it you can, okay, so one exercise mostly that happens in industry where you may have to do this exercises, you may have to pull out the all the employees whose name starts from certain letter. Or let's say you have to take your string data and do some formatting. Maybe there was some dirty data, unorganized, unformatted, and you have to format them. Put every first character in the uppercase and rest all as usual. So this sort of things are likely to happen, and this is just as an example. You may pull even the middle letter. That's up to you based on your requirement. For something like this, you have a requirement. So you have to either pull a single character, or you may have to pull a combination of character. Maybe I need this py together to form some string. Okay, maybe this represents a suffix or prefix. So I have to do this form of exercises, and this all can be achieved through indexing. So the indexing, there are basically two types, and one just called indexing. Indexing syntax is this way. You have to understand the syntax. This is the syntax. Your string object, whatever is your string variable name, like in this case, my string is the string object, basically string type. Okay, and it's called object because, as I said, everything in Python is an object, because here string is a class, and we are creating an object of type class, string class. So this is an object. Now, so what I have to do, string object, square bracket, okay, and then the index number, whichever particular character you need, because for that character, what is the index number? You know, every character has a unique index number. Although some character you can have the same character repeating multiple times, so by value they are same, but by position they have distinct position. So this is called indexing. Indexing always gives you a single character. This helps you to get a single character, okay, at any particular index number. There is another thing called slicing. Okay, slicing helps you to get a chunk of characters, not a single, but a group of them. Maybe I'm interested to slice from here to here. Can you see the highlighted part? Okay, so I want PYT, all three of them. So how can I get all three of them? Of course, if I know the start position and the end position, okay, so if I know this start position and if I know this end position, I can just slice it out from the rest of the string. Yeah, so that's the idea. So based on that, the syntax for slicing goes this way. This is the syntax where again string object, and then you have to say start index colon end index. Listen to this carefully. Or you can also say same as string underscore object start colon end. Now again, this is just a syntax, okay? Start here represents index start and this is index end. But the two important point here is where string is read only up to end minus one position. Why end minus one position? See, assume if how many characters are there in this string? Can you count it? So there are 6 characters, right? But if you are what is the last index? Since it starts from 0, the last index is 5. So that's why in terms of index, the last index will always be up to n minus 1. And if n represents the length of the string or length of the string minus 1. So that's what I'm saying, where a string is read up to end minus 1 position. So whatever you pass here as end, it will read 1 before, such that start equal to 0 is the default value. Okay, so these are optional to pass. If you do not pass start, default is 0. And likewise, end equal to length of the string object is going to be the default end value. Make sense? Okay. So based on this two information, let's take one example. So first I'll do it with indexing. So as I said, doing with the same example, I want to extract just letter P from my string. How can I do it? So that's my string. Let me create it. It's created. You can check it here. Oh, that's my string, Python. I have to get just P of it. So P is at what index? 0. And I get a P. That's simple. What if I need another letter? Up to you. You decide what you want. For simplicity, I want the last one now. Last is nothing but N. So I know N is nothing but, since there are 6 total letters or characters, 6 minus 1 is 5. That will be corresponding to the last character. Okay, that's indexing. Now going to the slicing, I'll put with the same example. So that's my string. Just to show you what's the latest value of my string. That's the string. Okay. And what we are doing now, here is my requirement, get py. I want to extract py, not just letter, but the substring. That's a substring. Substring represents they are continuous. There is no breakage. For example, we wish to extract p and n together, like pn instead of py. But what is the problem between p and n? There are some characters in between which we are not taking. So slicing supports extracting of a continuous block, okay, no discontinuous block. Now so you might ask yourself, what if I need Discontinuous block. Can you do that? Well, yes, you can do that. There is a way to do that, but not through slicing. Slicing just pulls out a chunk of together or substring, right? So I say it again, substring. This time I want O and N on, right? Okay. So here it goes as per the syntax, which says between start and end you have to give. So what is the start for P? That is 0. And for Y, what is the start? What is position? That is 1. Okay. So I want to read 0 and 1 together. So what I said, whatever you pass as the end parameter, it will read one lesser to that. One lesser to that. So since I want to read up to 1, I have to give here 2. What I said, since I have to read up to 1, let me show you again. Since I want to read up to this index, 0 and 1. So I have to give my index pointing till t. Okay, because whatever index I'll pass, it will read one lesser to it. That is basically up to py. I hope that's clear. Okay, so this, okay, let's quickly first see the output and then we'll proceed and see some more cases. And here is the output. Okay, now I could have done this other ways also. Since I know 0, I'm starting from beginning. And if I don't give my start value, that also means starting from beginning. So if I do this much of code, that will also give me py. Make sense? All right. Likewise, if I have to get now on is nothing but last two characters of your string, this two part. Correct. So what is the last index that I know? That's nothing but 5. So, but I want to read up to 5. So I have to give 6 here. Starting from what position? Starting from 5. Remember, start is always inclusive. Only end is exclusive. Okay, just to let you know once more, start is always going to be included and end is exclusive. Simple way. Okay, so I'm going to read now 5. Not 5, sorry, 4, that should be 4 to 5. 4 and 5. So that gives me on. Likewise, I can also, I know the default of the end is going to be the last element. Given that I put a bound on the start, that will also give me on. Is that simple? Sounds good, right? Okay, so what we saw by indexability property, it means that you can slice or you can index your characters of a string based on its index position. Now that could be indexing single character or indexing a chunk of characters. So when you want to index a single character, you can do through indexing following the syntax here. You just pass this index number, that is called indexing. And whenever you go ahead and out a segment or a content substring out of a string, more than one character, you can do it through slicing. And slicing takes both basically a bound or interval, start and end position, and it gives you a substring. Let's see the next property is called immutability. This is something again a different property of a string compared to C, C++. What does immutability means? Okay, so here it goes. You understand that a string is nothing but a combination of characters. Combination of characters arranged in some order, that's called string. And you can also slice them by character on character or index them by their index position. So it's possible that you may also wish to modify them, right? I may say, okay, I want to replace T with, I want to pull out T, then replace it with something like M. Okay, you may wish to do that, but what will be the consequence of that? The consequence will be that the meaning of this word will altogether change. You will lose your data, right? What if you don't want to lose your data? Then you have to basically protect it from overwriting, and you have to protect that. And to get this itself intact, to make sure your text data is not easily overridden by anybody, string has immutability properties. And what that property says, whenever you want, sorry, my string, that's my string, and that says, whenever you have a string, and if you want to modify a particular character like this, or a set of either a particular character or set of characters like this, whenever you wanna do this, you cannot do it just by assigning something new like this with assignment operator. This is called assignment operator that helps to assign back value to the left side variable, right? So it says whenever you have a string, with the help of assignment operator, you cannot modify just a particular value of your original string. And this way, that's what it says. How it says? By throwing an error. If you see, it gives a type error. Whenever you will try to modify a particular character or a set of characters of an string with by assigning a new set of values with the help of assignment operator or equal to operator, you will get an error that will read out this way: string object does not support item assignment. That simply means you cannot modify the original data. Okay, so that's the property of a string immutability, right? So the question, is that clear? You cannot modify the original data. Yes, just with the help of assignment operator. That's what string immutability means. So if you have a question right now, if I really have to do this change, I was talking like I really want to wait. I want to replace, let's say, I have a requirement. For some reason, let's say, okay, let's do it. Let's say actually have a, sorry, I actually have a data like this. Instead of O, you have at the rate and then N. And how did this data come from? Assume it was because of some data corruption. Some data corruption happened and O was replaced with at the rate. And now you want to correct it back. Okay, now you want to correct it back. So you have to basically replace your at the rate with O. How can I do this? How shall I do this? So Python says this, well, you can do this way. Uh, Actually, I'll come to this later because you need to cover up one more concept to achieve this activity. Okay, and so let's keep this pure right now, and we quickly pick up on more properties of string, and then we'll come back to this problem, right? Let's jump to the next properties called strings can be concatenated. What do you mean by concatenation? I think if you go in its literature meaning, concatenation is nothing but placing um, two objects side by side or top and bottom. That's what concatenation means. So Python says whenever you have two strings and you really want to concatenate them, you want to attach them side by side, you can make them a single string by attaching them together. You can do that with a plus operator. So have you guys ever seen this operator? any point of time you must have. In school days, I mean, we use it so often for math. Basically, this is called addition operator. We use it for adding two numbers, right? True. In Python also, you can also use this operator to add two numbers. So 2 plus 2 is 4. But beyond this, this operator has an additional properties for a string data. What it says, okay, when you'll have two strings like this, right now there are two strings. Of course, I can say, let's say string 1 for simplicity, and then string 2. I have two strings like this. So whenever you have two strings and I want a final string like this, Python language, that's my expected result. Okay, expected string that I am expecting. How can I achieve that? So it says whenever you have two strings, you concatenate them with your plus operator. Whenever you have two strings, if you want to place them side by side, join them together to get a single string, just call plus operator and you concatenate them like here, right? So if you see now Python language, of course, there is no white space as I wanted right now. Okay, so yes, plus operator does not add any white space by default. It will just attach two strings side by side. Now, if you need any white space, that you have to take care about it. You have to make sure you get that additional white space between them. Now, I get Python language. Okay. Now, so this is what the string concatenation means. You can concatenate two strings with the help of plus operator. Okay. This is called operator. We are familiar with this terminology. I do not have to highlight for you, irrespective of what background you are. These are mathematical terms, operator, operands. So you should be knowing that. Now, you can ask me, okay, on that note, can I also do this? 2 plus 2. So what is happening here? Both are 2, but in terms of technically, this is of int type and this is of string type. So can I add them together? Well, Python says no. If you try to do this, you will get the error, type error, where the message will be unsupported operand of types for plus. Basically, it's saying you are trying to concatenate or add. Basically, it's acting like an add operation. You are trying to add a number with a string, which does not make sense. And that is true. Practically, you should not do that. I mean, do we do in real time any such computation on a calculator plus some name? No, we don't do 2 plus 2, 2 plus 2.4. That's how we do, right? Because addition, which is an arithmetic operations, are supposed to be working with the numbers, not on a string data. That's the reason this is an error. It is not supported. So this will is an invalid operation as per Python. Okay. So what are the valid operations? Either both of your operands around plus operator, they should be of numeric type or they should be of completely string type. It cannot be a mixed type, right? That's what it says. Okay, on this note, I want to bring to your attention one more operator called asterisk. You guys would have seen these operators very often. This is also a representation of multiplication or product operator. If you do 2 into 2, that should give you 4. Or if you do 2 into 5, that should give you. So this is an multiplication operator that helps you to multiply two numbers. That is true in case of numbers. But what if one of your operands, let me repeat it, one of the operands is of string type? If that is of a string type, then this happens. Have a look. 2 into 5. Now, that is actually making my 5 turn to 55. It's a magic, but that's a true. So, okay. So, basically, when okay, now this is a special case. It does not happen with every operators. There are exceptions for plus operator and asterisk. This is called asterisk operator. Only for this, some different behavior happens with string, and that's why I'm highlighting them while we are on the working strings. So whenever you multiply a string with an integer, so the string will be replicated so many times. Okay, that's why this is called a replicator operator in when while working with a string. Okay, whenever you work with a string, that's called replicator operator. What if I make it 3? So 5 will be repeated basically 3 times. If I make it 9, 5 will be repeated 9 times. Basically, you get a string where 5 is occurring now 9 times. So it's repeating my original character. Is that clear? So we are clear with string concatenation. In string concatenation can be achieved with the plus operator where both of the operands needs to be of string type. And whenever we have to replicate an string content n number of times, you can go ahead and multiply it with an asterisk operator. Now, let's go back to our previous question. Here, we have to basically um, now achieve our target. We know that strings are immutable. We cannot replace a single or set of characters. Rather, not just this, you cannot do this too. Both are invalid operations. So, now what I have to do, I really have to replace because I know my data has some issue, that if some corruption has happened, I have to correct it and replace it with, for a particular value, I have to replace with uh, the correct data and get my string. How can you do it? So you have to do this way through the help of string concatenation, indexing, slide and slicing. Concat indexing and slicing. These three together can help you to achieve that. So what you have to do is first, till all the data before that corrupted point, whichever are your correct, basically correct data, you have to pull that out. So between 0 to 1, 3, 4, between 0 to 3, you have correct data. So what I'm going to do is, let me run that. My string 0 to 4. Okay, what you got? You got PYTH, except at the rate, before at the rate, whatever you have, you got it. And then my string of 5 will give me n, correct? So I got my last character. I got my starting characters. Now what do I need in between? I need O, right? I need O. So what happened now? So look at this, the result, Python, correct? Now if you notice carefully what's happening, you have slicing, string slicing, plus some new letter, new character, plus you have indexing. Okay, and this all together called string concatenation. Correct? So basically through slicing, indexing, and string concatenation, I have achieved my result. But now the point is, has this result or this operations changed my original data anyway? Let's check out. So I'm just displaying my original data after this statement. I have already executed this statement. Let's do that once more. And let's see, still my string, which is my original data, is intact as it is, or there is any modification. If you see, the original data is still as it is. There is no modification. So what that means, this operation is just an operation which does some sort of manipulation by reading the data from your original string and then gives you a new string which is stored at a new location, not on the same location. And it is also not changing my original data. So my original data is still preserved. So any operation that preserves your original data but also helps you to achieve your result, those are all applicable with string. But any operation that modify the original data anyhow, partially, that will not be applied to a string. That's why strings are called immutable. But again, in case if you're not interested to hold your original data, because now you're sure you don't need it at any point of time, and you want to modify and completely replace, you see this complete replacement of the string with the assignment operator is possible and acceptable. However, with some indexing and slicing like this, if you do, that is not allowed. This may not be allowed. Okay, so this 0 to 6, um, this is invalid. Basically, 0 to 6 will give me the entire string. I'm trying to replace the entire string, right? This is not valid. However, I can completely do this. This is valid. This will work. Okay, you can check yourself. You can just write the same, copy the same stuff, and you can run on your system. You will get an error for this code. However, I'm doing the same thing, but just that I'm not adding this square bracket and some sort of indexing and slicing. And if I do that, it is supported in Python. And if you see after this operation, my string is completely modified. Okay. So this is totally possible, right? All right. So that's what it means. And you can think of achieving some operations with string. Let's now go to the next section and try to understand what are the inbuilt methods. What do you mean by inbuilt methods? Well, method is nothing but a function. It's just that methods, a function that is a part of a class, it's called method. So terminology is different. So what I'm trying to say, let's study about inbuilt functions that can be used to work with strings. Right. So assume again we'll take some string. You know, my string is also a valid string. So whenever I want to see what are the inbuilt functions for a string, valid inbuilt functions available to work with the string, you can do this task. Okay. You get your valid any object, string object, then type dot and then press your tab button. Once again, you have to type dot and then tab button on your keyboard. If you do that, it will open this drop down prompt for you on Jupyter Notebook at least. And then you can see a lot of names. These are nothing but function names or method names. And these are all the methods, valid methods. Of course, each of this method has some purpose, but all of this you can use to manipulate the given string. What you have, what do you mean by manipulation? Of course, not changing the original data, but by doing some sort of manipulation on the existing data, creating a new string, manipulated string. That's what it is. So capitalize, if you see its purpose is, that's a function. You can read the documentation by pressing Shift and Tab. Let me repeat that. You can read the documentation by pressing Shift and Tab, and you can see valid methods by pressing dot and then tab. Okay, that's a bonus point. Okay, let's come back. So let's see in the documentation what capitalize does. So capitalize returns a capitalized version of a string. What do you mean by capitalized version? Capitalized version is nothing but the very first character of your string should be uppercase. If you see in our string, we don't have uppercase. So now if I run capitalize, it will make it uppercase. Make sense? Okay. There are many more, but if you see our original string is still lowercase because this operation has read information from my string, done some manipulation and created a new string, still retaining my original string. Okay, which that's the reason. There is something called title. Title converts again. Um, okay, so the difference you'll understand this way. Let's say it's written as Python is easy to learn. That's a statement. If you call title, every substrings or every word first character is converted to uppercase. But if you are calling, let's say, just capitalize, that will just convert the first letter to the uppercase. That's the difference. Well, I would not through every method here given for the string. I just wanted to give you an example, but there are many methods. In fact, a few of them are very important. If you know how to work with them, your manipulation of string data or a text data will be very easier to with these methods. So I will give you just the name of those important methods. You just Google or through some sources, try to learn them, read through the documentation, take few examples, run through examples. Okay, because this huge list is very huge and it would be difficult to go through each one of them. I will simply elongate this video length, which is not required. We can cover some more information during the time. So I'm going to highlight some important methods, and those are this one. We must not miss them and learn them. Okay, so replace. Then it has learn about each digit, learn about yeah, count will be required, lower, upper, you can do partition, replace, split. Yes, I want you to know this. It will really help you if you know these methods. Alone. With this list. Join. Yep. So these are the few 4 or 5 important methods. If you know them very well, when to use them, how to use them, what are the valid features they have, you'll be really gelling with string manipulation. Okay. So try to learn them with your time. I will try to share a detailed document on them that you can always see from the website that I will leave in the description box. and you can just self-educate yourself from there. Let's go to the next section, which is going to be very interesting again. I understand the video length has already gone to a stretch, but you have to understand we are trying to cover Python in detail. So it will take time. In institutes, usually to cover this topics, what I'm covering here, it takes on average 6 hours. Okay. So I will try to make it shorter here, covering the main points. I'm giving you ample examples to practice with. And if you just follow the instructions, mark down the important points that I say, that should be good enough for you to start. Keep a good note of all this. We will definitely use them. I know we did. I'm not asking or encouraging you to go coding for today, because I'm just trying to give you kind of introduction of the existing stuff. We still have to use them and write the program, which will be from the next maybe after 2 or 3 more topics, and we'll be able to write and do some small programs. And certainly, I'll ask you to code there by pausing your videos. Right now, let's see what we can do with print and input there. So a lot of the time, what happens, Python provides a lot of inbuilt functions, right? If somebody will ask you, okay, what does print does? Print is an inbuilt function that helps you nothing but to display your information on the output. Like that, we have many functions like we have print, input, chr, word, open. In fact, the whole list you can from W3 schools or any other authenticated website that you are aware of. Please refer that, read through this documentation and understand them. Again, you do not have to memorize them. All you need to know is whenever you need these functions, you should Google and read the documentation and make use of it. So print function basically helps you to print anything. Like you see, 3 plus 4, it's computing as well as printing as 7. There will be another print like a string message, as you see here. Again, Python is easy. I know I'm using the same example, but yeah, that's not a point. Point is, are we understanding it? That's a string. But a lot of the time, what happens, you have to really print some informative message. You just don't have to print some dummy examples like this. For example, there will be a scenario called, let's say, you have been given two number one like 40 and another number like 50. And you're developing a dummy application that or calculator that takes up this two number, adds them together, and then displays it on the console with a proper readable message like this. So 40 plus 50 equal to 90. I want to display a message like this. Of course, it should not be hard coded. Tomorrow, if I make it 100, that time it should automatically change to 100 plus 50 equal to 150. How can I do it? So you can do something like this. Um, num1 through string concatenation, you may try it. Num1 plus num2 uh, equal to num1 plus num2. Okay. My mistake. So that should be num1. Um, num1 plus num2 equal to num1 plus num2. Basically, these are strings. You remember, this is a string, and I'm concatenating a string with a number like this. But you know what's the problem? It will not work. It will give me Lot of syntax error because you know why? Because I'm trying to concatenate a string with an integer. Lot of issues, right? So instead of doing this jungling, I'll give you a tip here. There is something called format method that makes life very, very, very easy, and this works with the string data. So all you have to do is you create your watermark. Whenever you have to have a number, like first place I want to have a number, you replace, okay, you have to replace with a placeholder. This is called placeholder. Empty curly brace is called placeholder. Num1 plus num2 equal to sum. That's all. I'm reading out, okay? Num1 plus num2 equal to sum. Wherever I need to have a value, there I'm adding a placeholder. And then once I'm out of the code, I'm calling dot format. And then this is a method. To this, I'm passing num1, num2, and then num1 plus num2. Have a look. Very simple, isn't it? I mean, in the previous part where I was trying to form my message through string concatenation, a lot of syntax error, data type error, a lot of things came in. But here with the format method, could so simply just read out my message and get it. I do not have to manually do the typecasting, and it's that simple. It's just that wherever you need a value to insert it, put a placeholder, and this whole thing, which is a string, I can add inside the print. So whenever you have to print a formatted message, you write your message beautifully with the help of as a string with a proper placeholders, and you can place a value in those placeholders with the format method, right? So that is about print and format combination. Although Python supports a lot different ways of formatting a message and displaying, I would say this is the easiest one to do. So if you don't know anything as of now and want to stick to one, stick to this particular one. It is very good. And if you already know some other method and try to compare, if you like this, stick to this one. You need not, if you know anything extra, is always good, but this is not mandatory to know. I like to use format and it works very well with any format method. Let's come to next function, which is input. Okay. What is the use of input? So in the previous example, if the same example, let's say which I call dummy calculator, rephrase my message or my requirement rather this way. Uh, take, okay, read two numbers from user and add them. You know, in real-time application like calculator, users are the one who give the input, right? Don't do calculation on a fixed value. The user is given that opportunity to enter the value, read that value, and then do the computation. So like that, I want to do that. I want to take the values from users, number one and number two from user, and then do the summation. So how can I read the value from user? And so input function will help you to do that. Let's understand input first alone. Input, if you run that, that will give you a prompt like this, where you can enter your values like 50 and click on enter. I have entered my value, and then once I'm done with entering the value in the text box, I clicked on enter, and you see the value is read here. Now, if you notice carefully, there's a quote under the value, right? Can you see that? There's a quotation mark. What that indicates? That indicates whatever is read, that means 50 is read. I gave an integer 50, but it's reading it as an string 50. Okay, let's understand once more. I gave 100 and that gave me string 100. Let's understand once more. Okay, so see, just a blank box is not making sense. And as an end user, I'm not sure what should I give to it, what is it's asking for. Okay, so to guide the user, you can also give an message here. This way, enter an integer. Now see, this is a better way of asking for a number. Now as a user, I know, okay, this is asking for an integer value to be entered. So I gave integer. Now just reading this much is not sufficient. Whatever I did, I need to have to store to a variable, right? Then only I can use it later on. So I have stored it to num1. Let's print num1, comma, type of num1. Let's have a look. 70. So what happened? Num1 is displayed as 78, but if you see its type, it's a string type. Okay. What about if I read something like a special character called at the and here it goes. It is still read as a string type. What if I give a floating point, 78.9? That is still read as a string type. Okay, you see that? Which makes sense, which says basically, so that basically says input reads everything as a string. Whether you give a number representing integer or floating point or anything, it will convert everything to as a string. And so your num1 is also string. Now let's go back to this exercise. If I really have to implement those changes here, I would just go and do this part. Let's see what happens. So it gave me a first prompt asking for a number. I gave, or let's say I give 100. Then it asked me another prompt, which is 50. And now I was expecting the sum of 100 plus 50 as 150, but it gave me 1050. Correct? In fact, 10,050. So why that's happening? You see, that's because right now num1 and num2, these are of string type. And you know a plus operator works as a concatenation operator on a two string data. That's the reason the numbers are concatenated. And that's the reason you get this error. Not error, rather not expected output, an unexpectable output. So how can I correct this out? So I have to basically do something called explicit typecasting. That means the input that I got from user, they are by default in of string type. That is not suitable for my expected result or expected operation. So I have to explicit typecasting to bring it to numeric form and then perform addition. So to do that, I have to do this way. Num1 equal to int of 1. Likewise, num2 equal to int of num2. Now let's redo this problem and see if 150 when we enter 150 adds two different inputs. So first 100, then 50, and I got my 150. Now this is working well. Okay, making sense? Is it going interesting? Should be. But again, it's possible that as an user, I'm curious to not just add two integer numbers, but rather one integer and another float. In that case, is my base program complete and can it work? Let's see. So I give 100 and then I give 40.5 and I want to add them together. Ideally, they should get added together, right? Mathematically, 100 and 40.5 should be 140.5. And these are practical things. But what's happening if you do this, you will get an error. Okay. And if you can really read the error that says invalid literal for int with base 10. What that means, this means, look at this. It's pointing to a line number which gave you an error. So line number 7 gave me an error. Basically, error came from this line. So why that came, that basically means you are trying to convert a floating point, a string representing a floating point to an integer. Okay. So what that means in Python, uh, if you have a 45.5, that's a string. Do you agree? Yes, that's a string. If you try to convert 45.5 to an integer, you will get an error like this. This is not supported. Okay, and that's the reason I'm getting this error. But if you can give only 45, I mean a string representing only 45, what that means, a string representing an integer. When you try to typecast a string representing an integer to an integer, this works. Okay. So again, these are not any magic. These are as per rule. There are some constant. If you go to the Python official website, you will see over there this sort of examples, which is valid, which is not valid. So what Python says, int is the basically has the lowest priority. You can convert a string representing an integer to an integer. However, you cannot convert a floating point, a string representing a floating point to an integer. It's simple, right? So now the next question that can come to your mind, how can I solve this problem? How, if I really have to come up with a dynamic calculator, which can take both floating point number, integer, negative number, positive number, and that should work. I think that should work. Mathematically, they are possible. So how can I implement? Well, I'm not going to implement it here. Yes, I want you to try this out. And would you like to try? I will leave a hint in the Dropbox, but think about it. Give some time. How can you make this program workable for both int and floating point? Well, we'll see to that. In some time, we'll explore a few methods, and that should answer this part, right? Okay. All right. I have got two bonus questions for you. And if you just Google it, you'll get the answer too. So here you have to get the answer for this too. Once you get the answer, you'll be able to answer back to the previous question as well. In fact, implement this logic to a better way. Maybe after doing one or two more topics, you should be able to if you are just a beginner. So do not get worried. You cannot. For time being, focus on these two questions and then see if you can answer. So the first question is identify an string inbuilt method to validate a string representing positive integer. For example, you know this is a string, but the content of this string represents a valid positive integer. However, 45.a is not a valid integer. Because one of the characters is an alphabet. So this is an alphanumeric but not a valid integer. Another example could be 45.7. This is a valid, this string. See, technically they are strings, but Logically, this represents a valid floating point number, positive floating point number. There is another string like 70 or 87.9. When did we say this is not a valid floating point number? Why? Because there are two dots. By the definition of a floating point number, it, it can have maximum one dot, not two. So your task is to identify the inbuilt method from this in string inbuilt method toolkits to validate this. What do you mean by validating? That means if I have a valid uh, integer number representing, it should say, okay, uh, if I have a question, like my question is 45 a valid integer? What's your answer? That should be yes. So I need a method which should be used on this number, on this string, and that should return me S. By the way, this S is equivalent to Boolean true in Python. When I say the same question for the next line, that should say no, which is equal to Boolean false. And when I ask the similar question for 45.7, the answer should say yes. And when I ask the same question for the next number in the sequence, which is 87.9, the answer should be no, which is equal to false. So you have to get those methods, and if you can get it, you will certainly be able to work with rest of the logic and even correct out this logic, right? Is it making sense? Um, so explore it. Hint. I am giving up the hint for you. You can go ahead and try to read about these two methods. These two methods can help you to achieve these two logic. Read about this, Google about this, you'll get ample examples and then come back and try to implement this to out. I hope you liked the video so far. You have got at least some useful information out of this video. If you have any feedback on the video, try to leave them in the comment box. It will help me to review and revise my future contents so that there will be more informative information rather than uh, any additional noise which I would like to filter out before. With this, I'm just closing or ending this video on the basic data types right now so that I can make the video shorter. In the next sequence, I will try to cover all types of operators in Python. Till then, you have a happy learning and enjoy the content here.